Good evening, everybody. This is Troy Kilpatrick, the Journey Museum and Learning Center's Executive Director. Thank you for joining us as we journey into space here as part of our last video programming offerings of 2020. We bid a farewell to 2020, don't we all? It's been one heck of a year. But we're definitely looking forward to 2021 and our journey discussions. We'll be having a really great list of programs coming out soon. You'll be able to see the programs and the speakers that we have lined up. We'll be working on a calendar from January through April. It is our goal to keep bringing content to you guys on Thursday nights that you'll enjoy, that you'll be able to learn and be able to ask questions about. We chose to wrap up our calendar year with Journey into Space because it's got a lot of significance for us here at the museum. For Tally Monteau, let me introduce her just a little bit. I'll give her credentials. She joined our team the week that we upgraded this program that we use here at the museum. It's called UniView. And she joined us just in time, and we had our UniView representatives and everybody here, and we did a whole bunch of training in the museum. And within about 5 days, because of COVID-19, we had to close the museum. And so this new version with new images and new capabilities is something that we've been playing with kind of behind the scenes, because the world hasn't been the same for any of us. And so tonight's intent is for us to kind of show off some of the new stuff that we've learned. Tally herself joined our team. She graduated from Santa Glisca University, taught for 19 years in the tribal school. She's actually a qualified Lakota language coach. So she's working on the executive director, trying to teach him how to speak correctly. And tonight, Tally, this would be a Journey into Space, Journey Discussion 1G, right? Number 1. So there, see, I'm a slow learner, but I'm trying. That's the whole idea behind the Journey Museum and Learning Center. But we're blessed to have Tally on board because she can bring so many different things to this. And one of the parts of this program tonight, there's going to be a pre-recording on Lakota culture, or Lakota astronomy, or ethnoastronomy, something that Tally and our team has created previously. And that's going to be a pre-recorded segment. And then we'll jump to, and then Tally's going to fly us through the universe. And I've instructed her to not spend so much time on the primary planets, because if you've joined us over the past couple of years, you've probably had an opportunity to see Journey into Space. And so you've seen and heard us talk about Mercury and Mars and Jupiter and all the planets throughout the solar system. I highly encourage you to come and see us again. We're open Friday and Saturday as an example, where you could see the program where we focus a little bit more on that. But we're going to drift off into some of the moons and some of the other items that have been upgraded into the universe. And we're going to fly hyperspace. We've got our space travel on quick tonight to try to get you to see lots of different things. I'll be you guys out there who are watching, you can send a chat question at any time and I'll moderate. And so once we get through the 8-minute pre-recording and then Tally leads her section, she'll close with she's ready. She can handle some questions. I'll be the question asker or moderator tonight for all of you, but you can send them at any point. I manage that so that Tally can just continue to fly the UniView program itself as we go through the universe. A quick shout out. I mean, you might wonder, how does the Journey Museum and Learning Center end up with all this space science? Well, we're actually an affiliate member of the South Dakota Space Grant Consortium. And part of our role is to really inspire STEM education in all kids. And we hope that we can get young boys and girls interested in wanting to go on to an undergraduate degree at one of our state's universities. That's kind of our role. The rest of the folks in the Space Consortium, they're all our universities across the state here. We're really excited to be a part of all of that. And so just want to make sure we do that. One last thing, Tally. I didn't read my notes well enough. There's some music that we use in the pre-recorded segment. That music was provided by the Black Hills Chamber Music Festival. Michael Hill, we thank you. We had done some programs this summer, and they had generously allowed us to use some classical music to go with space because it just kind of fits so well together. And so we want to give them a shout out as we all make it through 2020 and we start headed towards 2021 with high hopes that things are going to get better for all of us. At this point, I'm going to turn this over. And again, this is going to be the pre-recorded segment of our journey into space tonight. And this is going to be about 8 minutes. And then Tally will fly you through the universe and then we'll turn it over to questions. So thank you all for joining us tonight. And I will be quiet and soon you're going to see the video.
Welcome to Lakota Star Knowledge. In order to understand the creation story or the origin story of how the world was created from the Lakota philosophy and perspective, we have to go back to how we believe our world was created. In the beginning, only Iya and Ha-Hempi, which is darkness, existed. Iya was a massive entity of power and energy, and Ha-Hempi just existed as darkness. Iya took from itself and started to mold an orb, a disc-like shape. When he was finished, he named this shape Maka, which is earth. Maka existed in darkness and started to ask Iya questions. So when you understand the creation story, as Iya was creating all these entities, he also gave them human-like characteristics, so they felt emotions. So Iya was alone, and she was asking him questions. Why am I here? What is my purpose? Is there anything else? So Iya took from himself and created Bewi, which is the sun, and Wichakfi Oyate, which is the star nation. As Iya took from himself and created Bewi, which is the sun, and Wichakfi Oyate, the star nation, Maka began to complain again that she couldn't see herself. She was cold, she felt ugly. So that's when he created Bewi, the sun, to warm Maka, warm earth. And from that, he also created Wichakpi Oyate, which is the star nation. So now that Maka was warm, she went to Iya once again and let him know that she is too hot. She needs a break from all the heat and what Iya command Bewi, who is sun, to rest at night so she can get some relief from his heat. So with that, Iya created Hawi, which would be sun's companion. So Hawi is the moon. Iya took from sun and created moon. She was lovely. He made her less bright than the sun, so the sun could gaze upon her beauty. So they were companions, and together they governed the daytime and the nighttime. While they were husband and wife until Iktomi, who is the trickster, intervened. At the Council of Sacred Beings, Trickster told Hawi to arrive late. When she arrived, she noticed that Ide, a beautiful woman, was sitting next to her husband, the sun. In shame, she covered her face with her shawl. Everybody was laughing at her because her husband was with another woman. So with that, she covered her face with her shawl and she ran away disgraced. So here we see her husband's son in the background. And we see Hawaii, which is moon, covering her face. Well, this goes into the lunar cycle of the Lakota calendar. There are 28 days, and the closer that Hawaii gets to Ambewi, she covers her face. So when she's closest to the sun, her face is fully covered with her shawl like this. As she moves away from him, she slowly begins to uncover her face. So these are the cycles of the moon. The further she gets away from him, her face is fully uncovered, and this will be our full moon. So as a consequence of the sun disgracing his wife, the moon, the sun was no longer allowed to rule with his wife, the moon. So now the sun governs the daytime, and Hawaii, which is the moon, is to be in charge of the night. Okay, so now we start talking about how the stars are relevant to our creation as a nation, as the Ocheti Shakawi. So we are looking into the nighttime sky. And two constellations of importance here to our creation story is the Big Dipper and the Little Dipper. So since we are in the summertime, the Big Dipper, which is the constellation on the top there, is the Big Dipper, which in our language is Wicha Aki Yuhapi, which means the carrier. They carried him. So in that story, they talk about how the leader went out hunting and he was injured and died of those injuries. So in this Big Dipper, there are 7 stars. 1, 2, 3, 4, 5, 6, 7. So the story goes that these 4 stars were his kolas, his 4 best friends. They found his body and they carried him. Behind them, while they were carrying the leader's body, the Itancha, the leader, were his wife, right here, his widower, and his 2 children. So that was the birth of our nation, and the 7 stars represent the Lakota, Dakota, Nakota Nation, or the Ocheti Shakawi, because they are 7 bands. So here we have 1, 2, 3, 4, 5, 6, 7. And that number 7 is significant to our creation story. So then we go down, and below is the Little Dipper. So now we begin our flight into space. Good evening. I want to introduce myself. I am Tally Monteau. I'm on the education team here at the Journey Museum and Learning Center. It's interesting watching that video because that's when I first learned this software, and now I'm a little more advanced as I have logged in many hours into space here. So what we're looking at right now is an overview of our solar system. We see the Kuiper Belt and we see all the orbital patterns of our planets. So the green are our planets, and then the blue are actually the dwarf planets. So in our solar system here, the center of the universe, according to scientific theory, is the sun. So the sun is classified as a middle-aged 4.5 billion years old yellow dwarf star. And it also holds up about 99.8% of our solar system's mass. So it's this huge, immense star. It's orbited by 8 planets, 5 dwarf planets, 379 asteroids, and as of this morning, 3,662 comets and over 200 moons. So our sun is a pretty big deal. Now we are going to visit the first planet closest to the sun at 36 million miles, also the smallest planet in our solar system, which is Mercury. Mercury is not orbited by any moons. Let me turn this little planet around here. So one thing we notice about Mercury is that it looks kind of scorched, and that is because it has a very thin atmosphere. And I'm going to be going through this kind of fast. One thing I want to point out here is the Caloris Basin, and it covers pretty much the surface of Mercury here. If you can see it right here, it just looks like a big gash. And what is a basin? Must you know? Well, geologists classify a basin as craters larger than 186 in diameter. So with this Caloris Basin, it measures about 950 miles across, and it's ringed by mile-high mountains. And one thing about Mercury is it has the widest temperature range in our solar system, with 880 degrees Fahrenheit here on the daytime side and up to a minus 290 degrees. There are the daytime side, and on the nighttime side, a negative 290 degrees. So it is not the hottest planet in our solar system. We venture off now to what is classified as the hottest planet in our solar system, which is Venus. And why is Venus the hottest planet in our solar system? Well, once we get there, I will fill you in. So one thing I wanted to kind of point out is that we kind of will touch base on the planets here, but not too much. I want to explore more into the moon, since we don't hardly ever get to see those. And during the daytime shows here at the Journey, we spend more time on the planets. So we get here to Venus. Venus is the hottest planet in our solar system because it is isothermal, has a very thick atmosphere. Those clouds there, those are sulfuric phosphorus clouds there. They're so thick, some of the rovers and satellites that they sent up there can't really get pictures of the surface. However, NASA sent up the Magellan mission, and it did radar imaging of the surface there, and it discovered that Venus is full of volcanoes and mountains. Some mountains, as the peaks are 20,000, which is Maxwell Montes, which is the highest mountain there, which we can't see. So it is isothermal, meaning that the temperature doesn't really range there. It's about 900 degrees Fahrenheit on the daytime side, and 900 degrees there on the nighttime side. Venus does not have any moons orbiting around it. And now we are off to our home planet, which is Earth. So all these other planets are named after Greek and Roman gods and goddesses, except for our home planet. Our home planet, Earth, is actually a Aramaic word, which simply just means the ground. However, indigenous peoples throughout our planet here have different names. In our area, the Lakota have the Earth's name as Unchimaka. The Mayans call Earth here Akna. And I want to kind of add our clouds in here just to show you the difference. So we saw Mercury, it looked scorched. And then we saw Venus, which looked real cloudy. And Earth has the perfect atmosphere. So this is an actual time here. So we see North America and South America. I just wanted to show you the clouds there, and I'm gonna get rid of them. So we're actually looking at the eastern part of the United States here, in the middle and the west. And down here is South America. And this is actual time. Kind of rotate Earth around here. We see all the other continents of Africa, Europe. And our first 4 planets are the terrestrial planets. I just want to kind of rotate Earth here and touch a little bit on Antarctica. One thing I discovered doing this program is that Antarctica is considered a desert. And why is that? Because it receives very little moisture or snowfall. And the small amount that it does receive collects into these thick ice sheets and shelves here that generate over hundreds to thousands of years. So I thought that was pretty amazing. I think of deserts as being hot. And we see this purple ring around Earth there. And what is that? Well, that is the International Space Station orbiting our home planet there. Kind of turn. So there are the early morning hours of Australia, Asia, the Philippines, New Zealand, the Pacific Islands there. As I rotate Earth around, I'm going to put her clouds back on. So it's pretty cool with this software that we can add these different effects. Sometimes I like to add the rings or the clouds, because soon as we start flying to other places, we can kind of see the Earth in the background. So we're going to take a quick trip to our International Space Station, which is a cooperative venture of 16 nations, including US, Canada, Russia, Japan, 11 members of the European Space Agency. It's the largest man-made satellite. I'm going to kind of rotate the International Space Station around here and zoom in so we can get a closer look at some of the flags that are there. We see the Earth in the background. The International Space Station weighs about 1 million pounds, the equivalent of more than 320 automobiles. I'm going to rotate around here. So it orbits around Earth here. And get a little closer. If I get you guys motion sickness, I apologize. I'm just trying to get you guys a really good view of the flags here. Zooming in. So right there we see one. Right there. See if I could get any that's as closest as they're going to let me get. And we see the NASA emblem right here. I know Japan's on here somewhere on the European Space Agency flag as well. So right here is the Japan flag and the European Space Agency right there. So it measures about 357 feet from end to end. That's the equivalent to the length of a football field, including the end zones for those of you who like football. So in it, it has a microgravity lab in which an international crew lives and works, all while traveling at the speed of 5 miles per second. And it orbits Earth every 90 minutes. So this is an awesome view of our International Space Station here. And we are off. Buckle your seatbelts. We are now off to the Earth's only natural satellite, which is the moon. I just want to kind of take a quick trip there because we're going to be visiting other moons in our solar system. And I want to give you guys a good visual of our moon compared to other moons in our galaxy here. So we say goodbye to Earth. Now we are traveling to the moon. So our moon has been visited by 24 human visits And we see an awesome view of the Earth in the background there. Half of those humans have actually moonwalked. If you guys can see, we have our Earth back here. The Apollo mission collected about 842 pounds of lunar rocks and soil that scientists are still now studying. And our moon, we see that it's cratered, and that's because it doesn't have an atmosphere and it's regularly bombarded by meteors and such. And usually I can get a view of the sun there too. So I just wanted to give you a quick view. It's been visited by over 100 robots. As we continue our journey here, we'll see other moons that look nothing like our moon. So now we are off to the red planet, which is Mars. And why does Mars look red? Well, that's because the iron in the soil there oxidizes. So it causes the atmosphere and everything on that planet to have this reddish orangish tint. As we fly into Mars, you'll see two pink rings around the planet there. And those are the two moons, Phobos and Deimos, that are there. Mars is about half the size of Earth, about 129 million miles away from the sun. I just wanted to kind of point out a feature here, if we can see it. We'll rotate this planet around. So right here, this gash or kind of like stretch mark there on the surface of Mars, that is called Valles Marineris, and it's a 2,500 mile long canyon and reaches up to the depths of 4 miles. So in comparison with the Earth's Grand Canyon, the Earth's Grand Canyon is only about 500 miles long, about a mile deep there. So that is a great picture. And NASA has 2 rovers that are there. We have Curiosity, which is right there on the surface of Mars. And here is Curiosity. If I can get us a good picture of Curiosity. So that's like an overhead view of the rover. I'm going to try to rotate it around here where we can see. Sometimes it's hard to get the angles right. We see a little bit of... One thing you guys don't see behind camera is I'm trying to do the software and look at my screen and do all my commands. So that is Curiosity. I guess I can't, the way Mars is tilted at this hour, I can't get a really good picture of it on the soil, so we can just get an overhead there. Let me rotate it around so we can kind of see. So we see that Mars is a really rocky planet. And then this summer, NASA sent up Perseverance, and Perseverance has not yet landed on Mars. And these 2 rovers will be sending back images of this planet to NASA. So we see Perseverance kind of floating around in space there on its way to Mars. Now we're going to visit the first of Mars's moons, and that is Phobos. One unique thing about this little moon, Phobos, is that it is the only moon that orbits really close to its mother's planet. So Phobos, as it's orbiting around Mars there, every century it gets about 6 feet closer to that planet. And scientists believe in about 50 million years or so that this little moon will either run into Mars or it will break up and become a ring around Mars. So we can kind of see Mars in the background there. And the sun. Some scientists believe that Mars's 2 moons are actually captured asteroids. They're potato-shaped. This moon orbits 3,700 miles away from Mars there, so it gets pretty close. And here is the second moon, which is Deimos. So Deimos has kind of a slower orbital pattern. It goes around Mars, takes about 30 hours to complete its orbit around its home planet there. It's a little bit smaller than Phobos. And we see Mars in the background there. So these two moons don't have enough mass and gravitational pull to make them spherical like our moon. Just wanted to kind of give you guys a quick view there as we say goodbye to Mars and head on to Jupiter. Also, now that we're leaving Phobos, it's a pretty small planet. So Phobos measures 9 miles by 7 miles by 6.8 miles. So it's a pretty small moon. Phobos is named after the Greek god of terror, and Deimos was named after the Greek god of fear and dread. As we fly into Jupiter, you see all those squiggly marks and lines, and that's because Jupiter is home to 79 moons. The largest planet in our solar system here. And Jupiter's makeup is mostly helium and hydrogen. We see one of the 79 moons orbiting right there. It's kind of awesome. I haven't done this program in the evening, so it's cool to see that. Down here, I just want to point out a few things. Jupiter is the first of the gas planets and also the largest planet. So these little white spots here are called the string of pearls, and they kind of grow and recede at different times as Jupiter completes its orbit around the sun there. And those are storms that go clockwise, and then the cores go counterclockwise. So that's why they have that pretty unique color. So all the storms here on Jupiter are all these spots that we see. All these different bands are the helium and the hydrogen mixing with supersonic winds, and there's no land masses there on this planet to absorb all that energy. So it creates all these storms and clouds that separate these gases, and that's where all the colors come from on this. Jupiter is 479 million miles away from the sun. And one thing about Jupiter is, since it has so many moons, they're classified into groups. There's the inner moons, the Galilean moons, and the outer moons. And scientists right now at NASA are actually studying the Galilean moons because some of them have oceans on there, and they're doing more in-depth research. Also, one thing I forgot to mention about Jupiter is that it is home to the largest ocean in our solar system, but it is an ocean made of liquid hydrogen instead of water. And we are visiting the first of the Galilean moons, which is Io. We come upon Io here. I'm gonna rotate Io around. The most significant characteristic about Io is it's the most volcanically active mass in our solar system. So we look at this little moon and it just looks tortured and tormented. It has hundreds of volcanoes that erupt lava fountains dozens of miles high on the surface there. I'm going to try to get you guys a good picture of Jupiter there in the background. And the Kuiper Belt is all that blue dots back there, and we'll get to that. So it's Jupiter there in the background. Io's kind of caught in between a tug of war between Jupiter's massive gravitational pull and another little moon that kind of orbits near it, Europa. So the significance of these Galilean moons are, even though Jupiter is the gas planet, the moons actually have some geological aspects to it. Like I said before, Io is the most volcanically active body in our solar system. And now we are going to Europa. And Europa is actually home to a salty water ocean that contains twice as much water in it than Earth does. And it's beneath the icy surface of Europa. Here we see Jupiter in the background. So we see all these fractures and these cracks here, these ridges and bands. The moon has an icy shell, probably about 10 to 15 miles thick. And beneath that is the ocean. So scientists don't have a real specific measure on that, but they estimate it to be between 40 to 100 miles deep, the ocean there. But this little moon also has a rocky mantle and an iron core similar to that of Earth. And now we are off to Ganymede, which is the largest moon in our solar system. So Jupiter is home to probably the most diverse moons in the solar system here. So we say farewell to the big old gas planet there, visit some of these moons. Once we arrive to Ganymede, you kind of notice the surface of it. And Ganymede is the only known moon to have its own magnetic field. So this is kind of cool. I guess I've never arrived on the nighttime sides of either of these masses here in our solar system. Let me rotate Ganymede around here. So this moon has its own magnetic field, and we can kind of view it. So Juno is the one that sends all these images back. Juno orbits around Jupiter and the area around it. And the last of the Galilean moons is Callisto. So keep that in mind. We are leaving the largest moon in our solar system. And now we're heading to the third largest moon, which is Callisto. So images of these moons were actually captured by, well, specifically Callisto was captured by a passing spacecraft. Juno is pretty much the go-to for all the images of Jupiter and the moons there. We see all the moons. And here is Callisto. So Callisto, scientists think that the bright areas here in Callisto are mostly ice, and the darker patches there are the areas where the ice is eroding. So even though Jupiter is a massive gas planet, its moons are more terrestrial, which is just a fancy word for land. And there are tens of other outer moons there on Jupiter that we really don't have time to visit. So we are off flying 886 million miles from the sun once we get to Saturn. So Saturn has the best name of the planets in our solar system, I think. Why do you guys think Saturn has such a good name? Anyone? Probably because it has a nice ring to it. Ha, 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 ha. So Saturn is home to 82 moons. It's actually home to the second largest moon in our solar system as well. And we will get there, and that is Titan. So we all kind of know about Saturn. It takes about 10.7 hours to complete its day and 29 years to complete its orbit around the sun. So one thing that is unique to Saturn is it's less dense than water because it's mostly made up of gas. But when it's doing its orbit, completing its orbit around the sun every 29 years, it actually appears ringless, and that is an optical illusion, and that's due to the tilt on its axis. So here I kind of simulated it. So it looks like there's no more rings, right? And that happens only twice every 29 and a half years. And that's just because of its tilt. And those rings are only 30 feet vertically. So they're pretty thin. Simulate that for you guys again. Now we are going to fly to the second largest moon in our solar system, Titan. So Saturn has all these supersonic fast winds. NASA's 2 Voyager spacecrafts actually are the ones that sent all these images back of the moons and the rings. So a few missions have actually visited. Cassini is the satellite that orbited the majority of the time around Saturn as well and sent us these beautiful images. And here we arrive at Titan. We see Saturn in the background there. So Titan, like Venus, has a very thick atmosphere. And that atmosphere is full of nitrogen gases. It's roughly about the same size as the planet Mercury. It's shrouded, like I said, in this thick nitrogen-rich atmosphere. And on the surface there of Titan are mountain ranges with peaks almost as high as 11,000 feet and several dozen lakes of liquid methane there on that moon. That's pretty interesting. So now we are flying to the second to the last planet in our solar system, Uranus. Back in my day when I was little, we had a different name for that. However, this is a kid-friendly show, so I am sticking with the scientific name. So Uranus is so far from the sun that it takes about 84 years to complete its orbit around, 1.8 billion miles from the sun. I'm just going to show you one quick, unique characteristic of this planet. Uranus is home to 27 moons. So as we arrive to Uranus, we notice that it's kind of tilted, right? So millions of years ago, scientists believed that this planet collided with another mass and it tilted it on its axis. And before this program, I had no idea that Uranus had rings around it. So there are 13 rings around this planet. And the seasons are also pretty long. On this South Pole, it sees 21 years of sunshine. And back here on the North Pole, it sees 21 years of winter time. And that's due to its unique rotation. So Uranus and Venus are the only 2 planets that rotate in different directions than all the other planets. So Uranian day is about 17 hours. Uranus was the first planet actually found with a telescope. So there are some cool things. Out of the 27 known moons, they're all named after characters from William Shakespeare's works and the poet Alexander Pope. So one of Uranus's moons is Miranda. And Miranda is the strangest Uranian moon, and its complex surface may indicate that scientists believe as an icy part of the interior is melting. So the core is melting and the icy material is drifting to the surface. So that is Miranda. We see the Kuiper Belt region there in the back. So the Kuiper Belt, as I rotate around, the Kuiper Belt is where the comets originate from. And that's kind of a new frontier that NASA is exploring. They think that some of the remnants of the creation of the solar system are found there in the Kuiper Belt. And now we are off to our last planet, Neptune. Neptune, some people don't think it's pretty significant. However, we will be 2.8 million miles from the sun. And once we get to the dark, cold ice giant of Neptune, we see an awesome view of the Kuiper Belt right there. It's kind of around our solar system. Neptune and Pluto share some of that Kuiper Belt in their orbital patterns. Neptune has 14 known moons orbiting around the planet there. Neptune is made up of hydrogen, helium, and mostly methane. That's why it looks blue. I'm kind of rotating around, but there we see one of the moons passing by there. Let me zoom in for you viewers here. Right there we see, I don't know which one that is, but it's one of them, one of the 14. So I'm on the surface there of, there's also another moon orbiting around right there. See that little spot? Neptune has these storms. And these storms that happen on this planet, which I can't get an image of, they must be on the nighttime side, and they're like darker looking spots. We see a little one down here as I rotate the planet around. Those storms are storms that rain diamonds. So mixed with all the 1,200 mile per hour winds in the atmosphere and the friction of the methane gases on the descent down, these storms actually generate 2.5 more times energy for that planet than it receives from the sun. So if you ever want to experience raining diamond storms, there it is. You can go visit Neptune. So now with Pluto being classified as a dwarf planet, Neptune would be considered the last planet in our solar system. And I kind of want to jump to Triton, which is Neptune's largest moon, 4th largest moon, I think, in our universe here. So we see Triton, and it orbits the planet in the opposite direction than all the other planets. I'm trying to get a visual of maybe Neptune in the background there, if I can rotate it just right. We see an awesome view of the Kuiper Belt region. Some of the nebula systems in the back there. So there we go. We got Neptune in the background there. Oh, I'm such a good pilot. Anyway, so Voyager 2 actually took these images of Triton, and it discovered that there's geysers on the icy surface there, and they spew icy material upward into space, the outer regions up to 5 miles. So that's just another visual of a different moon. The surface temperatures there get up to negative 391 degrees on that moon. And since I'm feeling a little nostalgic, I want to visit Pluto real quick before we wrap up here. So Pluto is a dwarf planet. Now what is a dwarf planet, right? A dwarf planet orbits the sun just like all the other planets. However, it's so small that it can't clear objects out of its path. So that's why it's called a dwarf planet, because it can't really protect itself. So we see the Kuiper Belt region there. And since Pluto is a dwarf planet, it's on the outer regions of our solar system, and its orbital pattern is in blue there instead of green. Pluto is only about 1,400 miles wide, so half the size of Earth. And the thing about Pluto is the ice is the white and the snow is the brown colors there. So we see that little dwarf planet there. And then one of its moons, Chiron, is actually significant because it never rises nor sets, and it just kind of hovers over the same spot on Pluto's horizon there. Trying to fly us around and see if we can get a picture of Pluto in the background, and there it is right there. So since it neither rises nor sets, it kind of rotates the same as Pluto. So those are just some real significant things that we can do with this updated version of our software here. And now as we kind of end our space flight here and exit, as we leave the solar system, we kind of find that our big yellow dwarf star and all the planets are just one part of the Milky Way galaxy. The Milky Way galaxy is this huge city of stars, so big that even at the speed of light, it will take 100,000 years to fly all the way across that galaxy there. I'll give you a good image. And that is the Milky Way galaxy. In my language, we call the Milky Way galaxy the Wanahi Ta Chanku, which means the spirit road. And when we talk about ethnoastronomy, we include some of those things in there. So if you ever want to have a program of ethnoastronomy, including the Ocheti Shakawi views on it, let my executive director know, and we could come up with a program for that. So on behalf of the Journey Museum and Learning Center, this kind of concludes our flight into space. If you have any questions, Troy will answer them for you or relay them to me so I can answer them. Thank you guys so much for joining us.
Thank you, Tally. We do have a couple little questions here, and so get your Kuiper Belt knowledge on. And the questions are on, I'm wondering if you could fly towards the Kuiper Belt while we're talking about that. The question that fielded here is the Kuiper Belt just considered part of our solar system or galaxy, or is it outside of our galaxy? And perhaps this is all linked to us looking at the Milky Way galaxy here. But I guess I'm not 100% sure of the Kuiper Belt's orientation. So can we talk about that a little bit?
Sure. So let me see if I could zoom out here. The Kuiper Belt is definitely within our solar system and galaxy. Kind of zooming out here. So scientists, they call it the donut of our galaxy because it surrounds our solar system here. And there's not too much known about it. Like I said in the presentation, that NASA is just now sending out, because it's so far on the outer parts of our solar system, that the satellites and the rovers that they send can only get so many images. So it's definitely part of our solar system. So you see these blue, these are the dwarf planets, and those are linked to the Kuiper Belt.
And I believe, Tally, I'm not an expert in this field, but the Kuiper Belt is one of the challenges for NASA and going to Mars, sending men and women through the Kuiper Belt. They're not 100% sure of what are the effects of the radiation within the Kuiper Belt. So just kind of, that's one of the challenges that NASA is taking on as they're looking to put people on Mars.
Yep, and I'm kind of doing an overhead view here of the Kuiper Belt. So we can see when we zoom out that it does encompass our solar system, surrounds it. So it's just a new frontier, and they're thinking of ways to get there so they kind of can explore it some more. One thing that they do know is that's where all the comets originate from, is this Kuiper Belt region, as far as I know.
So Tally, I think it's always fascinating. Could you take us outside of the galaxy so that folks could see, it's not even just the Milky Way galaxy.
No, so once we get back there, so we see all these little dots as we leave the Milky Way galaxy. And I'm going to kind of zoom in again. So we see all these dots in the outer part. So these red dots right here, these are other galaxies in the outer space region, all these little red dots. are different galaxies. And the Milky Way is considered kind of like a medium range galaxy, even though it's still huge. You know, at the speed of light, it will take 100,000 what did I say? 100,000 years just to travel across the Milky Way. We see all these little red dots right here. Those are different galaxies, different universes than ours. So that's just one thing to kind of keep in mind.
So Tally, we did get a request for us to create an ethnoastronomy program already. So we'll start, for those that are visiting with us tonight, we'll start working on that tomorrow.
Yep, and with these this program, we can kind of go so here we have the Tully Galaxies that I could kind of quick jump to. So that's a different galaxy. We can't get real good images, but it's see how it's floating there. Those are different galaxies there. I don't know if you guys can see, there's kind of a delay in the screen there. So we have
I'm sorry, Tally, go ahead.
Oh, okay, so we have the Tully Galaxies, the Able clusters. Some of these really don't have names, but on the software we have the Sloan Galaxies. So we don't have real good images. So this is kind of an image of the Sloan Galaxy here. And we can kind of see with these images that they are different than our galaxy, the Milky Way galaxy.
One of the things that I started to share with everybody is that the program is so vast that as we were just trying to prepare for tonight, we inadvertently ended up with about an hour and a half of content. And we decided, well, we're going to just kind of try to speed some of this stuff up. And again, you guys can ask us questions about things. And we're getting people chiming in on the ethnoastronomy, Tally, just so those are coming in while I'm talking here. So we're definitely got a project here for us. And I think it's something the journey will definitely embrace. I had to look up Perseverance, believe it or not, is going to land in February on Mars on a Thursday. Can you believe that?
Wow.
We're going to have to think of, maybe we can get Tom Durkin or someone from the South Dakota Space Consortium to come in and talk about Mars and Perseverance. And so we're openly asking people do you like those ideas, I guess? Do you have a question? And I don't think it can, but we have a question as far as whether we have any black hole images within the interview itself.
No, I was actually researching to see if we do. We don't. Our trainer that trained us on this software kind of gave us a link to some YouTube channels that do show them. So I did do a little research. I did find out black holes are actually the death of stars, and it sucks in all this magnetic, it just sucks everything in, and they don't know what goes on in there.
So for the person who asked that question, I get to throw out a quick commercial here. We actually have a program on black holes that is recorded in our video archive that you can see. It's under the Turtle Stories. It was done by NASA Space Ambassador Arjun Ayagar. He did that here at the Journey as part of him being a NASA Space Ambassador. So you can go and find that video. It's about a 45-minute program, and it's specifically about black holes, and it's available on journeymuseum.org. It's in our video archive under the Turtle Stories. So I was pretty sure the black holes didn't exist in the Uniview, but I wanted to ask the question so that I acknowledged the question from our audience. But at the same time, I knew that I could also steer you to the black holes program that had been previously done by Arjun, and I think you'll really enjoy it. Tally, did you have a favorite thing that you might have missed? Otherwise, I mean, we kind of admit we wanted to, like, if you guys want to come back to the museum and see more about the primary planets, we were really hoping to try to show you some of the moons, which we don't always get a chance to do in the Journey into Space in the museum.
So let me fly back to Earth here. Actually, I'm just going to jump to, we can do that with our software where we just jump to, and let me get rid of the International Space Station here. And I just want to kind of to touch base on, I talked a little bit about the Big Dipper. So
and while you're flying there, Tally, I noticed we've added a link to our programs in the chat box. So for those of you who are out there, you can click into that link and that'll head you over to like black holes. We did a little tally. We did a little total. I didn't mean to say a tally. I was trying not to play off of your name there, Tally, but I think we've created over 80 different educational videos here this year in 2020 because, we closed ourselves to the public to be safe for everybody. And we've really thrown ourselves into these video presentations. And so there's quite an archive of educational content, science, Lakota culture, history, all kinds of things is out there for you guys. We hope you would go out there and enjoy it and embrace it. So right now, provided.
What I have done is I have landed on Earth, and I'm kind of rotating around here because I just wanted to give us a view. This is how it would be. I landed somewhere up north there. And I wanted to get a view of the Big Dipper. Remember, I talked about how we are in a different season here. So I did that in the summertime, and the Big Dipper was kind of at a different angle. So now that we compare that pre-recorded video to now that we're in the winter solstice, we can see that the positions have changed with both of these constellations. So, as we kind of develop programs with the constellations, I have to keep up on my skills here learning this software. So one thing the audience doesn't know is that I'm navigating the software here on this computer and looking at the big screen. And I had a very good mentor that taught me how to do all this stuff, and our trainer. So I just wanted to
one of the things I think that viewers don't realize, because we take it for, you guys might have caught Tally commenting that she's not used to looking at Jupiter at this time of night. So Tally, talk about how we're happening in time with all the planets and everything. And so when we're using the UniView, we're actually broadcasting imagery in the timeline that's going on. So Tally, you want to talk about that a little bit, or did I just pretty much explain it? I don't know.
You pretty much explain it. So when we do our presentations live here, we have a morning Journey into Space program and we have an afternoon Journey into Space program. And when we do those programs, it is live and it's at real time. So some of the landmarks, like on the terrestrial planets, or some of the storms on the gas planets, we can't see because it's in real time. We do, however, have the ability and the capabilities in our software to speed up time, which I didn't do tonight. I did it in the pre-recorded video that we didn't show, because sometimes when you speed up time, you can kind of get a little bit of motion sickness. I'm still getting used to being an astronaut. But we have those capabilities to do that if we want to really see some significant landmarks or storms or things in space. We can speed that up. And normally I fly at space seconds to seconds, but since I only had a little bit of time, we traveled at milliseconds tonight. So I just kind of wanted to, and there's more we can do with the constellations. I just want to kind of to point out the different positions of the constellations because we are in the winter solstice now. Whereas in the summer solstice, the Big Dipper here was kind of tilted almost upside down.
So for our viewers too, I just want to share that this software in a normal year, We also have a traveling planetarium that goes to schools or goes to kids' fairs, those types of events. Obviously, so much has changed here in 2020, but that's part of what our education team throws themselves into, is the visiting of the schools and getting kids excited about astronomy and sciences. And so this is part of our evolving of this effort to continue to inspire, is to create programming now on Zoom and online and with videos. Someday we'll get back to taking those planetariums to the elementary schools and middle schools and high schools. Probably not right away here in the next couple months, given everything that we're up against. But obviously, we're going to keep working on all of this so that we can bring that forward. We're getting close to where we would wrap. If there's any other questions out there for the audience, my cue is clear, but I think we could answer another question. Or Tally, is there anything else that we appreciate you guys being with us tonight. We're ad-libbing a little bit just to show you how rich the software and the programming is. And if you do have ideas, aside even just from ethnoastronomy or black holes, or what kind of programs you'd like to see, we want to know, because we're here to educate. And if there's topics out there, we want to know about them. And yes, the museum is open tomorrow and Saturday. And then also I should mention, we do have a special. Tally is leading us through a journey through the journey between the Christmas and New Year's days. They're kind of a weird schedule. Please check out our hours at journeymuseum.org. We're doing like half afternoons and stuff, and the holidays are on Fridays, and we're open on Saturdays. And it's 2020, but we're trying. We're going to continue to persevere ourselves. But we're going to be open weekends, January through April. We're going to focus on being open Saturdays and Sundays so families can come see us. But as you guys have ideas for programs, please let us know. We're engaged in education. That's our goal here.
Any more questions?
Just housekeeping questions about our hours, and we've got that out of the way, Tally. And otherwise, I'm going to say, Tally, thank you for leading us through this journey through the universe and providing the Lakota ethnoastronomy story that you did provide. We'll work on more of that here at the Journey. It's a great thing for us to be engaged in, and I thank everybody who signed in with us tonight. We appreciate you so much. It gives us the energy. We're grateful, the energy to continue to persevere through what we're all contending with, and hopefully we're making everybody's days a little bit better by having these kind of programs where we can engage all of you at home in a safe way. So I'd like to just say thank you all. We feel very grateful for all of your support. And be safe, and we hope to see you maybe on a weekend here in the next few weeks. And we'll sign off tonight. Thank you all.